Hi, welcome to MedMadness. We use normal saline for hypotensive patients. We use mannitol for cerebral edema. We advise our hypertensive patients, hello Mr. X, please limit the use of salt in your diet. And still a lot of treatments based on this concept, right? What's the concept behind it? Let's go into the session. First, you need to understand about our fluid compartments in our body. Our total body water is 60% of our body weight. For example, take 100 kilogram man, he has a body water of 60 kg. That's a lot of water. In this 60%, the 2/3 of a volume is inside the cell and 1/3 in extracellular space. Let us see the diagram here. So it is 2/3 of a volume is inside the cell and 1/3 of a volume is in the extracellular space, that is outside the cell. The extracellular space has two compartments. One is the plasma and number two is the interstitial space. Note that you have 2/3 of a volume of extracellular space in the interstitium, that is in between the cells, and only 1/3 is in the plasma, right? So you have your major body water inside the cells. Now let's understand osmolarity of a fluid. I take a beaker full of water with a filtration membrane in between. Imagine this membrane is permeable only to water and not to the particles. In the A side, you have 10 particles and B side, you have only 2 particles. Now listen carefully, I'm going to change some words. The A side has increased number of osmoles or increased solute concentration or increased concentration of fluid or increased osmolarity when compared to the B side. Because we often use these words interchangeably in medicine. Now, the most important point. The difference in the osmolarity between these compartments will create a pressure and move the fluid. Now, the fluid moves in some direction. In which direction? The side B has decreased osmolarity and increased water concentration. Why increased concentration? Because we have decreased solutes. Side A has increased osmolarity and decreased water concentration. Now, the water moves from increased water concentration to decreased concentration, that is the side B to A. Now, imagine what you have some channels to move these particles. So, the osmolarity of a fluid changes, right? For example, this particle moves from here to here, this particle moves from here to here. So, the effective osmolarity of a fluid changes. So, water follows these particles and maintain the balance. Now let's take another example. I put RBC inside this beaker full of water. I'm going to change the osmolarity of the fluid outside the RBC. You know that our body osmolarity is approximately equal to 300 milliosmoles. The osmolarity of a fluid here, I put 300 milliosmoles. Will there be any movement of fluid here? No, there will be no movement of water because this solution is isotonic. Now I make 400 milliosmoles. Now there is a change in the osmolarity, so the fluid moves. Now the fluid moves from inside the RBC to outside the RBC and the RBC shrinks. Now when the osmolarity of a fluid is hypotonic, say like 200, the movement of a fluid from outside to into the cells and RBC swells up. We'll see some terms. So here, isotonic, you say it should be approximately equal to 300 milliosmoles. Hypotonic means less than 300. Hypertonic means greater than 300. I hope now you are very clear in this. Normally, the effective osmolarity in the extracellular fluid, we can consider 2 times that of sodium in milliequivalents per liter. So the normal amount of sodium will be around 135 to 145 milliequivalents per liter, right? You just double that and you see it will be approximately equal to 300 milliosmoles, which is the effective osmolarity of the extracellular fluid. Now we see some other examples associated with this. So this is a normal saline we often use to improve the blood pressure of our patients. Note the osmolarity of a saline here. It will be approximately equal to 300 milliosmoles. So when you give 300 milliosmoles of normal saline into our blood, this increases the extracellular fluid volume. Since the osmolarity is 300 milliosmoles, that is equal to our body osmolarity, there is no fluid shift. So the amount of fluid stays in the extracellular volume and increases the blood pressure. Now we'll see another example here. So in the renal histology session, I said the loop of Henle and the part of collecting duct is in the medulla. What is the importance in it? So the medulla has very high osmolarity. Let me zoom this image for you. So this is the cortex and this is the medulla. Note that a loop of Henle and a part of collecting duct is in the medulla. This is very important because this medulla has very high osmolarity, mainly contributed by urea. So the fluid is being filtered and moves in the nephron tubule like this. So you have very high osmolarity in your medulla. So this pulls the fluid from the nephron into the medulla. What is the importance in it? We'll see in detail in nephron physiology sessions. Now let's go for some more workouts. Now, to understand this concept more clearly, we are going to put this detail in a graph. In the x-axis, you take osmolarity, and in y-axis, you take the volume. And 1/3 of a volume is extracellular fluid, and 2/3 of volume is in intracellular fluid. Always keep these 3 steps in your mind for solving these problems. First, always check the ECF volume, whether there is an addition or loss of fluid. Number 2, check the osmolarity, whether there is increase or decrease in the osmolarity of fluid. Number 3, is there any fluid shift and what direction the fluid moves. Now first, when you are bleeding, that is hemorrhage, you lose fluid, right? You say it is isotonic fluid. Why? Because you lose your fluid as well as you lose your proteins. So it is isotonic fluid. So when you lose isotonic fluid, the ECF volume decreases, yes, and osmolarity stays the same. So there will be no shift of fluid. So the graph changes like this. Number 2, dehydration. For example, say sweating. Sweat is an example for hypotonic fluid because it has more fluid and less sodium. So when you lose your fluid without sodium, which means more sodium is retained in your blood, which increases the osmolarity. First, check the ECF volume. So there is a decrease in the ECF volume because of a loss of fluid, and osmolarity increases. So this is the new ECF volume now. And this ECF volume has increased osmolarity because you retain more sodium. What happens if you have increased osmolarity? The fluid is pulled from the cells into the ECF. So this is the graph now. Okay, let's move on to the next. You are giving your patients isotonic fluid. So there is increase in the ECF. Yes. Is the body osmolarity changes? No, it stays the same. So the graph is changed like this. There is increase in the ECF volume. You are giving hypotonic saline. That is, it is less than 300 milliosmoles. So when you add saline, yes, it increases the ECF volume. Now the osmolarity is decreased. So you have decreased osmolarity here. So the fluid moves from ECF to ICF. So the ICF volume increases. So the graph will be changed like this. Now let's give mannitol to our patients. So the mannitol has very high osmolarity, which is greater than 300. So the osmolarity will increase. So when the ECF osmolarity goes high, fluid will shift from cells into the ECF. So the cells shrink, leading to a graph like this. Very interesting, right? Let's move on to some more workouts. And now, pause this video and practice by yourself. You can send the answers to us. Email ID in the description box below. Let us summarize here. Okay, this is the take home point. Only if there is a change in the osmolarity in the compartments, there will be a fluid shift to maintain the balance. Water moves from higher to lower water concentration, and the direction of a flow is determined by the concentration of a solute. The greater the solute concentration is, and less water concentration will be. When the ECF osmolarity decreases, cells always swells up. When the ECF osmolarity increases, the cell shrinks. Keep that in your mind. If you have any doubts or topic suggestion, you can post in the comment section below. See you next session. Thank you.